Over the centuries, U.S. personal and population-wide demand for energy has grown exponentially. In fact, during the 17th century, personal demand was less than 50 million BTUs per person per year. During the 21st century, demand has risen to 332 million BTUs per person per year. Considering energy demand's rapid growth and only limited resources, innovations are needed that can help us responsibly manage our resources for many more years to come. Such an innovation is the smart grid. With the promise of improved efficiency and reduced total demand in the power grid, it has the potential to meet our future energy needs. A smart grid is an electrical grid that meets the world's ever-increasing demand for electricity by incorporating advanced metering infrastructure, like smart meters, which enable real-time power usage monitoring and two-way communications between energy providers and consumers. Compared to the current grid, this fully integrated smart grid will look radically different. It will resemble an energy web or energy internet with data and power flowing between all pieces of the energy puzzle. Real-time monitoring will create a more dynamic and sustainable power grid. Economic advantages aside, there are numerous environmental benefits of replacing an aging infrastructure with a smarter power grid. Currently, the demand for electricity from the power grid fluctuates throughout the day, with a peak load occurring in the afternoon. To compensate for this, backup plants are built for use during these times. These backup plants tend to pollute more and be less efficient than baseload plants. Smart grids will reduce the need for peak load power plants. A smart grid's success relies primarily on the idea that it can reduce peak loads on the grid by shifting some demand to non-peak hours. It does this by charging higher rates for power during peak times. These rates must act as appropriate market signals for consumers if smart grids are to affect peak energy demand. As consumers become more aware of their usage, they may attempt to reduce their costs by changing their energy use behaviors. The current power grid's coal and natural gas-fired power plants are responsible for a third of the U.S.'s greenhouse gas emissions. By reducing the demand for electricity, smart grids will address the problem of climate change by decreasing total greenhouse gas emissions. The smart grid's two-way communication technology will create an energy internet by allowing utility providers to allocate energy from small-scale energy producers like solar arrays and wind turbines to places that need it most. This will provide a stronger market for the renewable energy suppliers and energy to people when they need it. An estimated 62,000 plug-in electric vehicles were sold in 2012. Smart grids are essential to the integration of electric vehicles because they can be automated to reserve battery charging times for periods of lower energy demands and times of greater green energy production. Research to explore the smart grid's potential in the U.S. was mandated by the Energy Policy Act of 2005 to help tackle the 30-year project's estimated $200 billion cost. Smart grids are being installed in cities worldwide, but their potential benefits are still uncertain. Will the actual benefits and return on investment be enough? The need for more research into smart grids is stronger than ever. Our energy future hangs in the balance. Can we afford to wait? With the help of further policies and the deliberation of concerned, open-minded citizens, we can reach a cleaner, more sustainable future.